Inference is the task of making statements about things you can't observe. This lecture is about the ingredients you need to make useful inferences from data. So the goal of inference is to be able to make statements about things we can't really observe directly. And we also want to be able to characterize our uncertainty about those statements that we make. So these things that we can't observe, the things that we want to make inferences about, these are usually referred to generally as the population. Okay? And then to make inference, what we do is we collect a sample from the population. And the sampling process that we use results in our data set. Okay? So we have a data set that results from a sampling process that draws from a population. So to make inferences from data, you need three simple ingredients. First, you need to be able to identify the population to which you're making these inferences, okay? And of course, you have to have a question about that population, but that's kind of secondary. Once you've identified the population, then you can talk coherently about what you're making an inference about. The next thing you need to be able to do is to describe the sampling process. You need to be able to tell a story about how the data came from the population and ended up in your lab. Okay? If you can't describe that process, then it's going to be very hard to kind of understand how valid your inferences are from the data. The better and more clearly you can describe how the data came to you, the stronger your results will be. Now, the last thing you need is a model for the population. You need a model for how either elements of the population interact with each other or how they're related to each other. So defining the population is far and away the most important task. If you can't coherently describe the population, then you can't really make any inferences, okay? Because there's nothing to make inference to. So make sure that you can accurately characterize your population. It's going to help you tell the story better in the end after you analyze the data. So similarly, it's important that you identify an important question that you want to ask and answer. But presumably you've done this already, okay? So just as a very quick, simple running example, here's a basic population of 10 penguins, okay? And each of these penguins has a turquoise hat or a purple hat, okay? And so the basic question that we want to ask is what proportion of this population of penguins is wearing a turquoise hat, okay? So that's basically it. Now, the problem, of course, is that we can't collect data on the population, right? Because, they're penguins after all, and we can't take care of all of them. So we need to draw a sample from this population. So the sampling process is the manner in which the data come to you, and this gives you the data set. So let's say we're going to sample 3 penguins, okay? And the way that we sample those 3 penguins is we stand there in front of these 10 penguins and we take the first 3 that walk up to us, okay? So then we have our data set, which has 3 penguins. And so now the model for the population describes how the features or the units in the population are related to each other, okay? And this model can be more or less complex depending on the type of question that we're trying to answer. But the important thing is that the model connects the data that we observe to the population that we don't observe, all right? And so it's basically a little cartoon of how the world works. So a couple of examples of what a model might consist of is that we might assume, for example, that the units of the population are independent of each other. So imagine that the different penguins in this population are wearing different hats. And the fact that one penguin is wearing a turquoise hat doesn't really influence whether another penguin is going to wear a purple hat or a turquoise hat. So they're all kind of independent of each other. That's one assumption that we'll make that's part of our model. Another assumption that we might want to make is that certain features of the population are linearly related. So there are linear relationships between them. And there are many other kinds of things that you might want to assume about a population if your question is a little bit more complex. Now, the question that we're asking here is very simple. We just want to know what's the proportion of penguins with turquoise hats. So we don't have to make too many assumptions about the population in order to answer that question. So given our little data set here of 3 penguins, we want to estimate what's the proportion with turquoise hats in the population. So from the data set, we can estimate that it's 1/3 of the data set. 1/3 of the penguins have turquoise hats. So we'll assume that 1/3 of the population wears turquoise hats. So that's what we're going to infer from our data set. Our final estimate is 1/3 or 0.33 penguins with turquoise hats. Now it turns out, because we know the population, that the truth is about 0.4 penguins actually wear turquoise hats, or 2/5, okay? So our estimate is 0.3 roughly, and the truth is 0.4. And so the question is, well, how do we know if 0.3 or 0.33 is a good estimate? So we'll talk about that in the next lecture in terms of how do you know whether you've made a good inference or not. But the point is that our estimate is 0.33 and the truth is 0.4. So there's a variation there as we would expect. But that's our estimate for the population level feature.